In the United States, we use a system of measurement called the customary system, or some people call it the English system of measurement. However, most of the world uses a different system, and that is called the metric system of measurement. And this is a little bit about how you use the metric system. The first thing you need to know about the metric system is that it is not really a whole lot like ours. In fact, it's very different. It's based on using what we would call base units that relate to a specific kind of measurement. So for example, in the metric system, if you wanted to measure something of length, you would use a base unit of the meter. Or for volume, you would use a base unit of liter. Or for weight or mass, you would use a base unit of grams. Now those are not the only measurements, or at least they are not the only words that we would use, meters, liters, and grams, but they are the base units that would make up the rest of the measurements within the metric system. And to assist in allowing us to measure things in the metric system, we use what are called prefixes. We attach them to the front of the base units, and we come up with a new word that would represent a different size measurement. So just like an inch is different than a foot, is different than a yard, and so on, these prefixes change the measurement within the metric system. So as an example, there are a couple at the bottom of the screen. We have centi as a prefix plus meter would be centimeter. So a centimeter is a measure of length because it has that base unit of meter. And a kilo as a prefix plus liter would make kiloliter, and that would be a measurement of volume. Now the most common prefixes that we would use are kilo, centi, and milli. And for kilo, centi, and milli, we can see that they are located on different sides of that metric scale. Kilo is on the far left. It is actually the largest prefix. Centi and milli are on the far right. They are two of the smaller prefixes that we would use. And then also the base units that we typically use when it comes to the metric system are given in the middle, and we use those quite often as well. The other prefixes that you see, like hecto, or deca, or deci, we still use those, and they are very important to note where they are. However, we don't use them as often. Now, when we measure length, let's say we're using meters as our base unit, we can measure many things using meters. So, for example, like the length of a tree branch, we could measure in meters as approximately 1.5 meters. Or maybe the length of a room would be 5 meters. Okay, that's not hard to imagine. Or maybe the length of a ball of twine or yarn, if we were to unroll it and stretch it out, would be 25 meters. All of those are numbers that we can picture. We can imagine what 1.5 or 5 or 25 of some measurement would be. But when it comes to large measurements, it makes it much more difficult. For example, if we wanted to measure something like the distance from someone's home to the school, and let's say that that person lives approximately 10 miles from school. 10 miles is 16,093 meters. Now that's a really big number. And when it comes to imagining what 16,093 of something would look like, it's kind of hard to do. So what we do is we attach a prefix onto that base unit to make it easier to work with or easier to manage. 16,093 meters is actually equal to 16.093 kilometers or kilometers. Or if we wanted to round it, it would be 16.1 kilometers. And so 16.1 is a little bit easier to imagine than 16,093. We can picture what 16 of something would look like. But 16,000, much more difficult. And that's where the prefixes really help us. Now, the prefixes that we use are based on powers of 10. What does that really mean? Well, it means that as we move either to the left or to the right, that the units that we are using, the prefixes, get either 10 times larger or 10 times smaller than the previous one that we were at. As an example, if we looked at centimeters, they're 10 times larger than millimeters, or 1 centimeter is equal to 10 millimeters. To show you an example of that, if we were to look at the metric side of a regular ruler, we would see that there are some markings. On one side we have the customary 1 to 12 inches. However, on the other side, there are markings which measure centimeters and then also measure millimeters. Centimeters, as an example, I have a ruler. If we zoomed in on the 40 to 41 area, the 40 to 41 area measures 1 centimeter. But if you notice, there are a lot of little dashes in between 40 and 41 in the picture. And each one of those dashes represents the space of 1 millimeter. Now at the bottom of the screen, I've kind of enlarged that for you to show, hey, 1 centimeter is equal to 10 millimeters put together. So it takes more millimeters to make the same amount. And I hope that you note that this is not drawn to scale. It's just to show you what's going on. In the metric system, if we use the metric scale, as we move to the right to represent the number of each of the new units, we have to multiply by 10 because it takes more of the units further to the right to equal the same amount of the units that are to the left. As an example, let's say we're going from a base unit to centi. So the base unit, in this case, would be liters. Let's say we have 1 liter. 1 liter, if we multiply that by 10, would represent how many deciliters that we would need to have the same volume. So 1 liter would be equal to 1 times 10, which is 10 deciliters. If we move again to centiliters, since we're moving to the right, we have to represent that by multiplying the amount of deciliters, which was 10, by another 10 to represent the number of centiliters. So 1 liter was 10 deciliters, and then 10 deciliters times 10 would represent 100 centiliters. Or if we wanted to use grams, let's imagine we had 2 grams. To get to centigrams, we would have to multiply by first 10 to get to decigrams. 2 times 10 is 20 decigrams. And then we would multiply again by 10, which would produce 200, and it would be then centigrams. Now, a really easy way to help understand how those units change with the metric system is simply to move a decimal point. Each number either has a decimal point, or we can write with a decimal point even if it's a whole number. And as we move to the right, the decimal point moves to the right for each step on that metric scale. As an example, let's say we wanted to change meters, again a base unit, into centimeters. 1 meter would be equal to 10 decimeters, or 100 centimeters. Now I've represented underneath the word meter, or the measurement of 1 meter, as a decimal, 1.00. It's an equivalent decimal to the whole number 1. As we move to decimeters, if we move the decimal point 1 space to the right, it becomes 10 decimeters. And again, we move 1 more space to the right as we move on our metric scale to then show centimeters. Now let's go back to the example with the large value, which was kilometers, and represent the amount of meters it would take to equal the same amount of kilometers. This time we're moving to the left, and again, since we're moving to the left, we can move our decimal, but this time, instead of moving to the right like we did before when we were moving to the right on the scale, we would move our decimal to the left. So let's go ahead and take a look at what 16,093 meters would look like as kilometers. We're starting out at 16,093. Now that's a whole number. The decimal point in any whole number is given to the right each time. If we are to move from meters, which is the base unit, to kilometers, it would take 3 steps. 1, 2, 3. So what we need to do is we need to move our decimal point 3 times, and we will move it to the left because that's the way we're moving on the scale. Move once, twice, 3 times, and our decimal point ends up between the 6 and the 0 in our digits. Note that the digits did not change. They stayed the same. The only thing that changed was where the decimal point was located. If we clean that number up just a little bit by getting rid of the lines that we used to move that decimal point just to represent what was happening, we can see that the amount of kilometers would be 16.093, or rounded would be 16.1. Now, again, with the metric system, if we move to the left in the metric scale or in the diagram, you move your decimal point to the left for each step that you take. And conversely, if you move to the right in the diagram, you would do the same thing, move the decimal point to the right. So let's imagine we have kilometers. If we wanted to determine the number of centimeters, or the number of kilometers from a set of centimeters, we would move our decimal point 1, 2, 3, 4, 5 times to the left. So let's say we start with 400,000 centimeters. If we move our decimal point 5 times to the left, it would produce the number 4. So 400,000 centimeters, which is a huge number, could be better represented with kilometers and just saying that it would be 4 kilometers. Now let's say we start at meters and convert to kilometers. This time we don't have to move as far because we don't have as many steps. Again, only 3 steps. So let's say we have 4,000 meters. It would be equal to 4 kilometers. And to show that, we could take 4,000 again, a whole number always has a decimal point to the far right. And since we are moving 3 times, we would move our decimal point 3 times to the left. Clean it up. And now we have a decimal 4.000. By the way, that is an equivalent decimal to a whole number, so we could say just 4, again, kilometers. Now imagine we wanted to go from meters this time down to centimeters. Let's say we start with 5 meters to go to centimeters. Since centimeters are smaller, it will take more to make the same amount. We would move our decimal point 2 places, this time to the right. And in doing so, if we start at 5 meters, the decimal point comes to the right. We have to move it 2 times to the right. 1, 2. This time, we have some blank spots. Always fill blank spots with zeros as placeholders, and in holding those places, now they represent the number of centimeters, which would be 500 centimeters. You can abbreviate that cm. As we move on, going from kilometers to millimeters is the farthest we could go, or millimeters to kilometers. 4 kilometers would be equal to 4 million millimeters. 4 kilometers is 40 hectometers, or 400 decameters, or 4,000 meters, or 40,000 decimeters, 400,000 centimeters, or 4 million millimeters. In summary, remember that the metric system uses base units. They are meters, liters, and grams. Each step is a power of 10. When we convert within the metric system, we move our decimal place either to the right or to the left, depending upon how many steps we need to take.